Okay. So, I like doing all of the types of math that we've done so far in this class. I like looking at the graphs. I like looking at the tables. I like doing all of those things. But I don't like teaching it as much as I like teaching what we're getting ready to do. Because when you look at that graph, everything's going on in your head. You're not writing down and showing work. Whenever you look at the table, you might write down the values of the table, but you're not, everything's in your head, and sometimes that's hard for me to explain to you why the answer is what it is, and know that in your mind you're picturing what I'm picturing, right? So sometimes it makes it a little difficult to teach. Today we're going to look at limits algebraically or analytically, but either one of those two phrases can be used interchangeably there. And this is the stuff that I like to teach because it's a lot easier for me to correct your issues on this. This is like solving equation sort of stuff where, oh, look, you forgot your negative right here. That's why it's wrong. Or, oh, you factored this wrong. That's why you missed it. So it's a little easier to point out mistakes. There. So our first part is the easiest way to solve a limit, and that is direct substitution. I taught you a little bit of this yesterday because I had kind of, normally you know more about limits than you do because I didn't do these in pre-calc. So direct substitution is just plugging in the number, right? It is what you want to try first every single time, all right? So if we look at example 1 here, the limit as x approaches 2 of 3x squared minus 4. All you have to do here is do 3 times 2 squared minus 4. You're just plugging in 2 for your x. And so that's going to be 3 times 4 minus 4, which is 12 minus 4. So we'll get 8 for our answer for that. I don't care if you show your work on this or not. No, when we get to the longer problems, I do want to see some work just because I do not believe anybody is good enough to do all of it in their head. I do believe you're good enough to take a picture of this with your phone and photomath. If photomath can probably do this. I haven't checked. It can't do limits? It won't be long before photomath can do limits. Because this is the sort of stuff photomath. Yeah. So, okay. So 2 is one that sometimes is confusing because you're plugging in 0 for the x, but there is no x, so it's just 5. That's just a horizontal line at 5. So anywhere on the graph, it doesn't matter what x approaches, the y value is 5. So it's going to be 5 no matter what x approaches for that. And then for the last one, we're just plugging in that negative 2. So we'll have square root of 6 plus negative 2. That's going to give us the square root of 4, which is 2. And to Daniel's question about showing work actually is a really good question because on the AP exam, whenever you have to do this free response problems, if you just write 8 for number 1, that's fine. They do not expect you to. There are some things you have to explain or show your work, but arithmetic, so adding, subtracting, multiplying, dividing, raising something to a power, any of those things, you don't have to show your work for it. It's okay if you do those things in your head, as long as you get them right. So don't do them in your head if you can't do it correctly in your head. But I know that some of you, I'm sure, can probably do this in your head without writing anything down. In notes, I'll usually write everything down just so everybody's following what I'm doing. Because not everybody can do it in their head, necessarily. Okay? Questions? Alright, now, believe it or not, direct substitution is not all we're going to do in this section. Sometimes it is going to fail. I know you probably thought it was going to be that easy the whole time, but unfortunately, it is not. So there are two ways that direct substitution can fail. So I'll give you a second so you can copy this down and then we'll look at it. So if you plug in the number and you get a valid number out, so you get 7, you get -3, you get 2.58, you get 0, 0 is okay to get, then that's your answer. So if you can plug the number in and you get something out, that's the answer. But there are two times whenever you're not going to get the answer, and this is what we're going to ask you the most about, because these are those interesting points that are happening in the graphs where you might have jumps or asymptotes or whatever. So one way that it fails is that the limit does not exist. So if I plug 0 in here, I get 3 over 0. And 3 divided by 0 is undefined. Now 3 divided by 0 is undefined, but what do we say about the limit? Does not exist. So we would say here the limit does not exist. I'm going to do something for the second one that is technically wrong. And later, way later, like in a few chapters, I'm going to tell you you can't do it anymore, but I'm going to let you do it right now. Okay? So, I'm going to let you do it right now, but no, at some point I'm going to tell you you cannot do this. So, I'm going to plug in 5 here. So, I'm going to have 5 squared minus 4 times 5 minus 5 over 5 minus 5. So, that is going to give us 25 minus 20 minus 5 over 0, which ends up being 0 over 0. It's not 1. It's not negative 1. You can't divide anything by 0, even if it is 0.
Like if you could divide 0 by 1, not by 0. That would be
Right. It's fine to do 0 divided by 1 or 0 divided by 5. You can have 0 cookies and split them among 5 friends. But you can't have 5 cookies and split them with 0 friends, right? Or 0 people. Because the cookies got to at least be in some sort of group, right? They exist, so they can't be in 0 groups.
I remember in math 1, you got flip the second and multiply.
Yeah, that's right. Right. Yeah. 0 over a number is okay, a number over 0, no way.
That's
That's what I was thinking since we started.
Yeah. So, in this particular case, though, if we get a number over 0, it's undefined, we say the limit does not exist. If we get 0 over 0, this is what we call the indeterminate form. And it is what it sounds like, indeterminate. It means you cannot determine anything from it. So, if we get the indeterminate form, we cannot say the limit does exist or does not exist. We still don't know.
You can't determine it.
We cannot determine it. Unless we do more work and figure something out. Right? So, when it...
We do that later.
Alright, so, the reason that we cannot do this is because nothing can equal the indeterminate form. Nothing can actually be equal to 0 over 0. So it is incorrect to say that this equals 0 over 0. So it really doesn't matter so much now because these types of problems are pretty much always on multiple choice and not on the free response section, and you're not going to do this on them. But when we get to L'Hopital's rule, which we can't do yet because you don't know how to take a derivative, I'm going to tell you that you can't do this anymore, and instead what you're going to have to do is you're going to have to do the limit of the top half, and you're going to say that equals 0, and then you'll have to write the limit of the bottom half separately and show that as 0. And yeah, so you can't say it is. I also agree that it's stupid that you can't just say it equals 0 over 0. But I went to a training for AP a couple years ago, and the trainer told us that if it's L'Hopital's rule, which again we're not doing yet, that you cannot say it equals 0 over 0, and if you do, you will lose a point on that free response question. So, if you want to go ahead and just do it like this now, you can. The only thing is like you're not going to have to be necessarily showing your work on every single step, so you probably aren't going to have to write that down. So, but yeah, if you are worried that you are going to get in a bad habit of putting equals 0 over 0 a lot, you could just go ahead and write the limit of the top and the limit of the bottom separately.
Like top one, but if I erase the middle of the line sign, I'll be fine.
Yeah. Well, I mean,
It means like if you erase the lines, it technically looks like it's two separate problems. It's just like the bottom.
well, you still have to put that limit notation on top and bottom. So, yeah.
Put two arrows.
I don't know if they're going to let that fly or not. But where the notation really gets important is on L'Hopital's rule, which is still a long ways away. And I will explain it in much further detail there. Because what we're going to see is we're not really going to do this a lot. We're just going to check it sort of in our head, and then we're going to have to do something else. So let's see what we're going to do. Here, so if we get the indeterminate form, you've got to keep going. There's something else that you can do to figure out what the limit is. So the first thing we're going to look at is cancellation. Mm-hmm.
Where? Like the last one I understand, but this is not.
When you take an AP test.
So
Like this exact form.
limits are a basis we have to understand for derivatives.
She said something like that.
Yeah, and derivatives are actually useful. But this particular thing we need to understand, but as far as its direct application, we don't know enough yet to apply, because we have to take this and use it for derivatives, And then once we know derivatives, then we can use those for actual real-world problems where you would actually use this. So, this directly, no, but eventually it's going to lead to something that can be useful there. So every time you're supposed to try direct substitution, a lot of times I do that in my head, because you're going to see most of the time you're going to get 0 over 0. So I'm going to write it down, but you could do this part in your head. You don't have to write it down. You'd have negative 2 squared minus 3 times negative 2 minus 10 over negative 2 plus 2. If we really were wanting to be good, we could write these limits separate, but we're just checking this real quick. So we got 4 plus 6 minus 10 over 0, which is 0 over 0. So this is my indeterminate form. That tells me that I need to keep going. There's something else I can do. So what we're going to try first for this type of problem is we're going to try factoring and canceling. So the bottom won't factor. And everything I just did there, you can do in your head. You don't have to write it down. The problem is a lot of times we start assuming it's 0 over 0, and then they throw in a problem that's not 0 over 0, where we could have just done direct substitution. So, no. Yeah, a lot of times it won't factor, and then you can't figure out what in the world you're doing wrong, and you cry, scream, throw your book across the room. So you want to do this every time, but I'm telling you that you're probably not going to do it every time if you're like a normal student. Even I catch myself automatically assuming it's 0 over 0, and it's sometimes not. So we're going to factor the top and factor the bottom we can't factor. It's just going to be x plus 2. So x and x, how does this one factor? Minus 5 plus 2. Conveniently here, what can happen with our x plus 2's? They cancel right here. And so now once they have canceled, we just have the limit as x approaches negative 2 of x minus 5. And now we can just plug in the number. Direct substitution, negative 2 minus 5 is going to give us negative 7. I like these two. I can't remember if I did it with you, but we looked at like holes in the graph and asymptotes. I can't guarantee I did it with your class. So. Yeah. So, a few things again that we got to be a little bit picky for. Technically, you're not supposed to put equals 0 over 0, but right now you can do that in your head, so I'm not going to worry about that. So, limit notation. You must keep this limit notation until you plug the number in. So, the limit notation right here is required until you plug the number in. So, once I get to this part right here, because I was taking negative 2 and plugging it in, I no longer have the limit notation once I'm plugging the number in. But until you do that, you have to have that limit notation written out front. I, a lot of times, get lazy, especially if I'm trying to do a problem quickly, and I don't write any of the limit notation, which can get you in trouble if it's on a free response problem. So multiple choice, it doesn't matter. You can still get the answer right. All right, let's see. Do I want to teach you how to do number 5? You guys do not know how to factor x to the third minus 1, do you?
I'd say just go over it anyway.
I'm just trying to decide whether or not I want to show you this now, or I think I'm going to show you this later. Just because I don't want to show you how to factor x to the third minus 1 right now. Because you gotta, there's a whole new formula you don't know because we used to teach it in Algebra 2, and we don't teach it in anything anymore, so you don't know it. Okay, alright. Alright, so a to the third plus or minus b to the third factors into a, let's get my signs wrong on this. Am I going to have to look it up? I think it's plus. Is it in here? It's not right there. It's not. I don't want to write it down wrong. I'm pretty sure I know it, but I always get the signs mixed up. Here, I'm going to Google it. Factoring cubes. Yeah, okay. Matches. Okay. A plus or minus b times a squared minus or plus ab plus b squared. Mr. Brown may have done it. Possibly.
He wrote this down.
Okay. He may have done it. I don't think so. Whatever sign you have here, it's going to be the same sign here. So if it's positive here, it's going to be positive here, and then it's going to be different here. And then this one is just always positive. So, same sign, different sign, always positive as far as your signs go. It's minus or plus. So it's flipped upside down, meaning that where you had a plus or minus here, if you had a plus, it's changing to a minus here. Yeah. So if you had a plus here, it's going to be plus in the first parentheses, a minus right here, and then this one's always positive. If you have a minus, it's going to be a minus here, plus here, and plus here. So for this, I can write, I don't have an a cubed and a b cubed, but 1 is a perfect cube, right? 1 cubed is 1. So I can treat this like it is a cube right here. Or if I had something like x to the third minus 8, I could write that as x to the third minus 2 to the third. Because 8 is 2 to the third. So, when I factor this in the top, oh wait. First I should do direct substitution. Does this give me 0 over 0? It does. It gives me 0 over 0. But I should check that. So I'm going to factor the top. So you're going to have just the a, so it's going to be x in this case. Use the same sign, so use the minus sign. And then the b, so the cube root of 1 is just 1 here. And then our a in this case is an x, so it's going to be x squared. Different sign, so where I have a minus sign right here, now it's going to be a plus sign. A times b, or in this case it's x times 1, which is just x. And then the last one is always a plus sign, and then it's going to be your b squared, or in this case it's 1 squared, which is just 1. If he had Coach Wood, he probably did not do it. Which is okay. It's not actually in the curriculum. It's okay that he did not do it. Your homework's going to have some in it. I have never seen one on the AP exam, though. So I don't think I don't think you will need to know it for the AP exam. It's not. This is not a huge deal if you're not.
Is that a formula that we should know? No.
It's not a huge deal. If you know it, it might help you somewhere down the road, but it's not a big deal if you don't know. All right, so now we cancel. Now we can plug in our 1. Since I'm plugging in 1, I'm not going to use the limit notation anymore. 1 squared plus 1 plus 1 is going to give me 3, so 3 is my answer. I have never seen a factoring cubes on the AP exam. It doesn't mean it couldn't be on there. It just means it's probably not going to be on there.
So this formula is for factoring cubes.
Factoring cubes. Yes, this is factoring cubes. Which means that you got something cubed, either plus or minus something cubed. We used to teach it in Algebra 2, but it's not in the curriculum anymore. So it sounds like Mr. Brown taught it in Math 3, but you don't. It is okay that Coach Wood did not teach it to you because it's not in the curriculum anymore. All right, questions? Okay. Another technique that we can try is rationalization. So these are not calculus problems. I just want us to review rationalizing numbers. Okay, so rationalizing, we did this some in pre-calculus, you do it some in Math 3. It's this crazy rule that square roots can't be on the bottom of a fraction, right? Okay, here's the good news. In calculus, square roots can be in the bottom of a fraction. On the AP exam, if you leave your answer as 1 over square root of 2, that's okay. Alright, on free response, now I will say on multiple choice, a lot of times they have rationalized the answer. So both answers won't be there, so you still kind of have to know how to do it. But you don't have to do this. In fact, I tell students not to rationalize your answers because you might make a mistake and then you lose the point, right? So, but rationalization is a method that can help us solve limits sometimes. And sometimes you might rationalize the numerator instead of the denominator. So if I want to rationalize 1 over the square root of 5, what do I need to do? Very good. Multiply by that square root of 5 over square root of 5, which in the top is just going to give me square root of 5. What does it give me in the bottom?
25.
It'll be 5 because it's the square root of 25, which is 5. Good. All right, so this is just sort of like a pre-calculus review here. This is not actually the calculus we're doing yet. You may or may not have seen how to rationalize example 7. What do we multiply by here to rationalize? I'm not sure if you've seen it. 2 minus the square root of 6. We call this multiplying by the conjugate. Have you heard that big word before? And what it does is it gives you a difference of squares, right? Kind of like if you're doing x plus 3 times x minus 3. It's just going to be x squared minus 9. The middle terms cancel out, right? So it's sort of the same thing here. So we're multiplying by the conjugate. So in the numerator, right now I'm just going to do 8 times 2 minus square root of 6. In the denominator, I'm doing 2 times 2, which is 4. I'm going to write the whole thing out, although you can skip this middle part. You do 2 times negative square root of 6, which gives you negative 2 square root of 6. You do 2 times square root of 6, which gives you positive 2 square root of 6. And you do square root of 6 times negative square root of 6, which is going to be negative 6. So just distributing here, but what happens to those middle two terms? They cancel. So we end up with, we could distribute this if we want. We got 16 minus 8 square root of 6 over 4 minus 6, which would give us a negative 2.
And then can you do the triangle thing to simplify?
You could simplify this because both of those are divisible by 2. If it wasn't, you could just leave it, but they are both divisible, so you could have negative 8 plus 4 square root of 6. Example 6, we did a lot of, even in pre-cal, I made you do that with your answers. 7's probably a little more foreign to you.
I think we did that.
You probably did,
A
but
lot of times, people get confused about the square. You leave the square root out of it when you simplify, right? Like,
correct. Yeah, whenever you simplify here, 2's on the outside of the square root,
just like
so you're just dividing those coefficients,
Yeah.
not the square root of 6 here. Yeah. All right, so this is just a review of pre-calculus. Let's see what it looks like whenever we've got a calculus problem. All right, so with all of these problems, every single time, we're supposed to do direct substitution. You can do it in your head if you want, but if you plug in 0, you're going to get square root of 1 minus 1, which is 0 over 0. So we get nowhere with that, right? So that tells us we got to do something else. Again, you can do that in your head. You don't have to write it down. Most of the time, it's going to give you 0 over 0 because I'm testing to know whether you know how to do all this other harder stuff, right? So what we're going to do here, we've got a square root in the top. We want to get rid of the square root in the numerator this time. So we're rationalizing our numerator instead of our denominator here. Now, it doesn't matter whether it's numerator or denominator. Pretty much wherever your square root is, you need to try to get rid of it. Right? So, I'll rewrite this. I've got square root of x plus 1 minus 1 over x. So I've got to multiply by the conjugate. The conjugate is going to be square root of x plus 1 plus 1. And make sure you multiply on the top and bottom of your fraction. Okay? Notice here, this x plus 1 stayed the same. I didn't change the sign there. Yes. All right, so now in the numerator, I'm going to distribute. So square root of x plus 1 times square root of x plus 1 is, it's just going to be x plus 1.
Oh, yeah.
Because it's like x plus 1 squared, and then you're taking the square root, which cancels each other out. And then I've got to do, now I'm going to write it this time, but you don't necessarily have to write this every time because it's going to happen, if you've done it correctly, it's going to happen every time they'll cancel, right? Yeah. So you got plus the square root of x plus 1. And then when you multiply the inside terms, you get minus the square root of x plus 1. So it's perfectly acceptable to know those should always cancel out. That's why we chose the conjugate like we did, so they would cancel. And then we multiply the last two, negative 1 times positive 1 is negative 1. So these two cancel. In your denominator, do not multiply those together because you want something to cancel. No. Oh, I'm sorry. Yes, the ones do also cancel. You're correct. So in addition to those middle terms, you got a positive 1 and a negative 1, and they can also cancel. Yes.
How do you make the diagonal
it's always, what you're doing for the conjugate, you're always, whatever sign you have here, you change it right here. Okay, so whatever sign you have between the two terms, that's got to change. So if this was positive, we'd make it negative over here. All right, so this leaves us with the limit, limit as x approaches 0 of x over x times square root of x plus 1 plus 1. The x's cancel. And since there's nothing up there in the top, we're going to put the understood 1. So once the x's cancel, you should be able to plug in your 0. So you're going to have 1 over, don't have to use limit notation once you've plugged in the 0, square root of 0 plus 1 plus 1. And so square root of 0 plus 1 is just 1 plus 1. So we get 1/2 for our answer. I love these.
Well, that was nice.
I love them.
That's a lot of room for error. That was nice.
There's some room for error there for sure. Let's see. Let me look at the way I got left here. Oh, we got time. We can do it. All right. Okay. Here's your next one. Everybody's favorite complex fractions. Who doesn't like a fraction inside of a fraction? All right, so if we plug in 0, I'm not going to even write it here because we're running out of time, but if I plug in 0, I got 1/2 minus 1/2, which is 0, over 0. 0 over 0, indeterminate form, so I can't do anything with this as it is. So, I got to get rid of this complex fraction is what I need to do. So, dividing fractions is easy as pie, flip the second, multiply, but I don't have a single fraction in the top. I could technically go ahead and flip it. I would probably get common denominators in that top part first. Although there's more than one way to do this, so it doesn't have to be done this way, but so if I want to get common denominators, I need to multiply this fraction by 2 on top and bottom. And I need to multiply the second fraction by x plus 2 on top and bottom. And so that is, you're going to have the same denominator here now. So this is going to give me 2 minus 1 times x plus 2 over, the denominator is the same for both of these, so I can just write it once, 2 times x plus 2. And don't forget, this is still all over x, because I was only dealing with that numerator. Okay, questions so far? Alright, I can distribute my negative here. Don't forget your limit notation. 2 minus x minus 2 over 2 times x plus 2 all over x. And here I've got a positive 2 and a minus 2, so those end up canceling right there. So I've got the limit as x approaches 0 of negative x over 2 times x plus 2 over x. Now, at this point, I could make this a fraction. Dividing fractions is easy as pie. flip the second and multiply. So I got negative x over 2 times x plus 2 times 1 over x. Why is that good? You can cancel this x right here with this x in the bottom. Which is, this was a negative x right here, where we distributed that negative. So you got negative, this is like a negative 1 right here, right? So you're going to have the limit as x approaches 0 in the denominator. Yes. No, you're thinking of exponents. Negatives don't move. Only if they have exponents in it. Yeah, you just cancel and you'll just have this. So at this point, when something has canceled, you can probably use direct substitution. So I'm going to try direct substitution. Negative 1 over 2 times 0 plus 2 is going to give me negative 1 over 2 times 2. So I get negative 1/4 for my answer. Complex fractions are always everybody's favorite. There's like one like this, yeah. Maybe two, but you can do it. Okay, we got one more kind to do.
Oh, yes.
This is when you go home and show your parents your homework just so they're impressed with their sweet little baby, how smart they are.
I'm done with this. Are you going to upload this video to?
Yes, it will. Yes. Okay. So, something that you need to know. Delta x is your change in x. It is a single variable even though it looks like it's delta times x, right? So delta x, whenever you see it, it's like having an h. In fact, some textbooks use an h instead of a delta x. We'll see why delta x as we go along later, but right now, just know it's a single variable. All right, so delta x is approaching 0, not x. So like if I do direct substitution, I'm going to write it out real quick here. X stays here. But delta x is replaced with 0. Which means right here you get 2x squared minus 2x squared over 0. And as you can imagine, it's going to be 0 over 0, right? Of course. Alright, so here's what you got to do. Here's what you got to do for this one. Not long. Alright, you have to, whenever I have this squared, I'm going to expand. Which means I'm going to write over here side, I'm doing x plus delta x times x plus delta x. If you need to, write it out here. Or I usually square, double, square. So square the first, that's going to give you x squared. Multiply this together, which is going to be x times delta x, and double it, and then square the last. Yes. Yes. All right, so what I'm doing there, I'm doing it in my head. I'm doing square, double, square. So I square the first, which is that x squared right here. Then for your double, you're going to multiply the two terms together, which in this case is x and delta x. So that's just x, delta x. And you double it, which is where that 2 came from. And then you square the last term, which is delta x. Or if you need to, go over here to the side. X times x is x squared. X times delta X is X delta X.
So
Over
delta
here,
X
X delta X.
So delta X times delta X is not.
It's delta X squared.
Okay.
Because delta X is just like having an H.
And delta
H
X,
times H would be X
and
squared.
delta X plus delta X does not equal 2 delta X.
Yes.
It's 2X delta X.
Well, it's because you're doubling. You got to do X times delta X first. Because right here, you got X delta X plus X delta X, which is 2X delta X. Alright. Okay. Alright.
What's the next step? Okay.
Distribute. Two X squared plus 4X delta X plus 2 delta X squared minus 2X squared over delta X. Okay, so I just distributed that 2 to the parentheses. At this point, do you guys see anything that will cancel? Can't cancel delta X yet. It's this 2X squared and the negative 2X squared. If you've done it right, the only stuff that should be left should have a delta X with it. Anything without a delta X should go away if you've done it right. So you can see here I've got 4X delta X plus 2 delta X squared. So both of these have at least one delta X. So I can factor out the delta X. So I'm going to pull this delta X out here. And I've got 4X plus 2 delta X over delta X. And I'm going to put the limit notation out here. If you see a problem with a delta X, everything except for delta X should cancel out. You should be able to factor out one delta X. Right? Now, since I've factored out that delta X, what can happen with the one on the bottom? Cancel. Okay? Now, you're going to plug in 0 for delta X, not for X. Okay, so you got 4X plus 2 times 0, which is going to give you 4X, which is your answer. Your answer has an X in it.
I wrote 4.
So basically, you do the same thing that you're doing on just delta X.
No,
Yeah.
if photomath doesn't do this,
Photomath can't do that.
I'm done.
Okay. All right. Yeah, y'all. Not even the premium versions. You pay for it just to see. All right. Here is your assignment. Yeah. It's on Canvas. Yeah, it's posted on Canvas. Yeah, the page. Oh, no, not a picture of the page. The assignment's there, but I did not put a picture of the page. Just go ahead and take a picture real quick. Please note, most of those first ones are direct substitution. They should be quick. It's this 51 through 66 that you're going to have time to spend on.